Here we go. Start it back up. See how far we can get on this one here. Sorry, it takes just a little bit of time, and sometimes it doesn't want to recognize me on my camera, and I don't know why. But we should be ready to fly here in just a second. Okay, there we go. So, taking a look here, matching. This is n squared minus 64, difference of squares. N plus 8, n minus 8. So that is F. So if I look at this guy, I would hippo butt, n squared is what times what? These are both pluses. So that's going to be a plus 8 and a plus 8. Those are factors of 64 that add to 16, which is n plus 8 squared, which is C. This is a difference of cubes, little hippo cheek, big hippo cheek. N minus 4, n squared plus 4n plus 16. That's got to be this guy right here, A. This is a sum of cubes, little hippo cheek, big hippo cheek. N plus 4. It's going to be n squared minus 4n plus 16. And that is D. Alright, we're done. 29, write a third degree polynomial in factored form, negative 2 and 3, the only zeros. So you're only given 2 zeros. So x minus a negative 2, which can become plus, x minus 3. But it says that it's a third degree, which means one of these has to have the square. Doesn't matter which one. You can put the square on either one. So I would accept either this answer or that one. Either way works. Okay, write it in standard form with these zeros. How many zeros do you see? 1, 2, 3. So 3 hippo cheeks it is. Start out with x minus every time. Then just take the zeros and plug them in. Negative 1, that changes it to a plus. Negative 2, that changes it to a plus. And then 2. Multiply the ones that are exact opposites if you have them first, because things will cancel. X times x, x squared, minus 2x, plus 2x, minus 4. They canceled. X squared minus 4 times x squared plus 1, x cubed, plus 4x, plus 1x squared, minus 4. Writing in standard form, I get x cubed, plus x squared, plus 4x minus 4. You're done. Okay, here we go. Oh, I think that's a full class ticket, folks. X times negative 4. That should be a negative 4x. Negative 4x. There you go. Full class ticket. Least degree polynomial with integer coefficients. Standard form. These are my zeros. But wait a minute. There's a square root. So if there's 1, there's got to be 2. So I see 4 hippo cheeks there going on. X minus, x minus, x minus, x minus. Plug them in. Square root of 2, negative square root of 2. It's going to be plus. Negative 1, it's going to be plus, and 0. So we'll multiply these guys first. Things will cancel. X squared plus x square roots of 2 minus x square roots of 2. It's almost as if I knew they would cancel. Negative square root of 2 times negative square root of 2. Negative square root of 4, which is just 2. So that's x squared minus 2 times x plus 1, and then times x. Now, if I were you personally, I would multiply these two first, and then multiply the x into everything. So I get x cubed plus x squared minus 2x minus 2. Now I'm going to multiply everything by x. It's going to be x to the 4th plus x cubed minus 2x squared minus 2x. Done. So, how many zeros do you see? 1, 2, but wait a minute, there's an I. So if there's one I, there's got to be 2. So that means I have 3 hippo cheeks. X minus, x minus, x minus. Put in the 2, put in the 2 minus 3i. Put in the 2 plus 3i. Distribute in your negative. It's going to be x minus 2 plus 3i. It's going to be x minus 2 minus 3i. Going to multiply those guys first. X times x squared. X times negative 2, negative 2x. X times negative 3i, negative 3ix. Negative 2 times x, negative 2x. Negative 2 times negative 2, negative 4. Notice he's not a like term. I put him out here. Negative 2 times negative 3i plus 6i. Still not a like term because it doesn't have an x. Now multiply by the 3i. 3i times x, positive 3ix. They cancel. 3i times negative 2, negative 6i. They cancel. 3i times negative I, negative 9i squared. But I squared is negative 1. So this is a positive 9. Combining like terms, we get x squared minus 4x plus 5. Okay? Now we're going to, by the way, how come you guys aren't stopping me when I make mistakes, knuckleheads? What's a negative times a negative? That's a positive. This should not be 5. This should be 13. 13. So now I'm going to take x minus 2. I'm going to multiply it. That sounds like another full class ticket. Plus 13. So distribute x cubed minus 4x squared plus 13x. 2x, my negative 2x squared plus 8x minus 26. So combine like terms, I get, I'm going to put it right here. No, I'm going to put it right here. X cubed minus 6x squared plus 21x minus 26. There it is, done. Write this in factored form. Please be careful. Make sure you read directions carefully. Just factored form. Square root of 5 has multiplicity of 2. That means there's 2 of them, which means there has to be 2 negatives. 2 plus 3i means there's a 2 minus 3i. 0, negative 4. Okay, so I count 1, 2, 3, 4, 5, 6, 7, 8. 8 hippo cheeks. X minus, 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 X minus. Plug in your zeros. Square root of 5, square root of 5, negative square root of 5, which makes that plus, negative square root of 5, which makes that plus. 2 plus 3i. So distributing in the negative, I get minus 2 minus 3i. 2 minus 3i, which distributing in the negative gives me a minus 2 plus 3i. A 0 and a minus 4. To be honest, you'll never really see it written as x minus 0, but if you did, I wouldn't mark it wrong. You normally just would see that. Sorry about that, guys. There it is. Normally you would just see this as an x. But there's your 8 hippo cheeks. Done. Woo! Okay, 34. Sketch a graph. I would tell you the first thing to do to sketch a graph is figure out your zeros. You have one at 0 right here. This set equal to 0 and solve would be at a negative 2. This set equal to 0 and solve would be at a negative 1. And look, it occurs twice. Oh, something special is going to happen there at negative 1. That's right, it's going to bounce. Now that I've determined my zeros, those are my x-intercepts right there. 0, negative 2, negative 1, negative 1. If you want to write them as coordinate points, great. Take a look. X squared times x is x cubed times x is x to the 4th. So my degree is 4, but it's negative, which means both end behaviors are going down. I know a negative 1 is going to bounce. So this thing is going to look kind of like McDonald's sign right there. Loving it. Okay, number of local max. My local number of maxes. I don't have any. Oh, locals, yes I do. I have 2 local maxes, but they're also global because they are the highest point, I'm pretty sure. Number of local mins, 1. Number of local mins, none. Okay, let's graph this guy right here. So find your zero. Set this equal to 0 and solve. I get 1. Set this equal to 0 and solve. I get -3. But whoa, wait a minute. What's that little 3 right there mean? It means that this 1 occurs 3 times. We call that a multiplicity of 3, by the way. But my x-intercepts are 1, -3. I don't have to list out the 1 3 times, but I know it's there 3 times. It will go through because it's an odd number, but it will flatten right there at 1. My degree. X cubed times x is x to the 4, so degree is 4, but this time it's positive. So both ends are going up. So this one came through. It's going to come and flatten right here and then go up. So it's going to kind of look like that. Number of local maximums. None. Global max? None. Local min. Some people argue that a global and a local are the same thing, so I guess the argument could be out there that there's one, but then global there's one, meaning there's one full global max, or min, sorry, one full global min. Okay, 36. Says it wants us to sketch this big bad boy. First thing is to find your zeros. I'd always try to factor, but there's 5 terms. Can't factor, so you have to go to the rational root theorem. Factors of 9, plus or minus 1, 3, and 9, over factors of the first, which is -1, which happens to be plus or minus 1. So these all divided by 1 is the same thing, so I'm going to try 1 first. It gives me a -1, -2, plus 8, plus 18, plus 9. Look at it, you have -3, ain't no way in hay. So positive 1 is out. Try -1. Cool thing about -1, these numbers will stay the same. The only thing that will change is their sign depending on if it's an odd or even power. Even power, they stay the same, so it's -1. Odd changes the sign. Even stays the same. Odd changes the sign. -1 plus 2 is 1. 1 plus 8 is 9. 9 minus 18 is -9 plus 9 is 0. So there's one of my x-intercepts, or zeros, -1. So if the 0 was -1, that means it came from a factor of x plus 1. So I know -1 is on my graph. I'm now going to synthetically divide -1 into this. -1, -2, 8, 18, 9, -1, 1, -1, 1, 9, -9, 9, -9, 0. This drops down from an x to the 4th to an x to the 3rd. There's 4 terms. Try to split it down the middle. Factor out a -x squared. That's going to give me x plus 1. Factor out a 9. It's going to give me x plus 1. There's another 0 right there. So -1 occurs another time. From right here. Now negative, leading with it, don't like it, factor it out. So I have a -x squared minus 9. Now I have a difference of squares, x plus 3, x minus 3. So -3 right here, if set it equal to 0, is a 0 and 3. So normally we'd write this as -1 multiplicity 2, which means something cool is going to happen to -1, -3 and 3. So -3 and 3, and behavior. Even, negative, both going down. We know a -1 is going to bounce. So this goes through, bounce, back through. We're supposed to go through 9, but that's whatever. It's way up there. Y-intercept is 9. Don't worry if it doesn't quite match on your graph. It's okay. Domain, -infinity to infinity. Range. Without a calculator, we don't know the range. We don't know the top part here. So I'd say -infinity to a max. If you have a calculator, you can calculate that by putting this equation into your calculator. Going to second trace, down to I think number 3 or 4. One of them says max. Left bound would be here, right bound would be here, and then guess, and then just hit enter, and it'll take you right to your max, and that max value, that y value, would be your maximum around your range. And behavior, as x goes to negative infinity, f of x is going to go to negative infinity, and as x goes to infinity, f of x also goes to negative infinity. Okay? Woohoo! Got any more? Whole nother back page. See what we can get done. Here we go. So I tell you to factor this thing first. Factor out a negative x squared. It's going to give us an x minus 3. So there's one of your zeros. Right here, x equaling 3. So that's an x-intercept at 3. Well, x squared, isn't that just x times x? And if I put 0 in for x, 0 times anything is 0, and it occurs twice. So 0 has a multiplicity of 2 because of that squared. Ooh, so something cool is going to happen at 0. This is a negative odd. Okay, we're frozen. I don't know how, why. Oh dear. Maybe I hit something. I apologize. No. 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 Okay. I don't know how to get off of this little stupid thing here. Okay. Can you still? Okay, now you can see. Okay. So now, take a look. Take a look. Take a look. Again, negative, odd, which means they're going to go in opposite directions, and it should be decreasing overall. You know, at 0, it bounces, comes through. There's the sketch, y-intercept, 0, 0. Domain, negative infinity. To infinity, range, negative infinity. To infinity, end behavior as x goes to negative infinity. F of x going to infinity. As x goes to infinity, f of x going to negative infinity. Done. Write a cubic function in factored form for the graph whose given x-intercepts are integers. So I see 2 zeros, x minus the 0 here, that's a negative, that's going to become plus, x minus the 0 here, notice that it bounced. It's got to be a square. Now does that satisfy our cubic part? X squared times x cubed. Now it's either got to be leading with a 1 or negative 1. Notice that it's going up. This is going to be a positive 1. Done. Use the graph at the right to tell if the degree of the polynomial shown is even or odd. First of all, they're both going in the same direction, so you know it's got to be even. And the leading coefficient has to be positive because they're both going up. Both going up, positive. Both going in the same direction, even. It says graph the function as a domain of all real numbers, a local max, a global min, and no x-intercepts. So if it only has a global min, it means it's got to keep going down further. No, it has a global min, that means the lowest it can go. And a local max means it has to keep going up. So this thing's got to look something like maybe that. Notice this one is a global min. There you go. It didn't say we couldn't have a local. If we couldn't have a local min as well, this would have to come down to be the same height as that. Then notice it doesn't hit the x-axis. Okay, we're done there. One last page. Let's see if we can get through it. Explain how algebraically determine if a function is even, odd, or neither. Sure. Remember, even means it's reflected over y-axis, which means algebraically basically this. If I plug in an x value that's positive, or if I plug in an x value that's negative, they will equal each other. So if it's on this side or this side, if it's even reflection, they will equal each other, whether it's positive or negative x. Odd, we say reflects over both, or we say over the origin, which is the x and y axes. What that really means is if I put in an x or put in a negative x, I will get complete opposite values. So in other words, if I put in a negative x and get a value here, when I put in the same positive x, the value should be down here. And that would be then reflecting over the origin. Okay? Perfect. says use this graph here to determine, it's a quintic, so fifth degree. Determine the number of real and number of non-real. How many zeros do you see? 1, 2, 3. There is no flattening anywhere, so there's only 3 reals. And there's no bounces. Doesn't bounce anywhere. So 3 reals. That would mean if it's a fifth degree, I have to have 2 non-real roots. Okay, done. 43, which of the following polynomial functions could have the graph shown? Well, we know that has to have an even degree. So x times x times x is x cubed. Can't be that one. X squared times x cubed times x could be this one. X times x, that's x cubed. Can't be that one. X squared, x to the fourth could be that one. Now, has to have a 0, -1. That means x minus a -1 is a +1, and it bounces at x plus 1 squared. So x plus 1 squared is this one. D is my answer. B is out. Woohoo! We flew through that guy. 44. Which of the following statements are true about this polynomial function? Be careful. The degree of p of x is even. They are going in the same direction, so yes, that's true. The degree of px is 4. 1, 2, okay, 1, 2, 3, 4, 5, 6. False. There's 6 zeros. Cannot be 4. Leading coefficient of p of x is negative. They're both going in the same direction, up. False. Can't be negative. It's got to be positive. The degree of p of x is at least 6. That is true. Because it could be tighter here. We don't know. Could be maybe like this could be 4 zeros right here. The graph has a y-intercept of 150. That's false. Has a y-intercept of negative 150. Has 4 distinct zeros. Okay, that is actually true. Even though those zeros have multiplicities, it has 4. 1, 2, 3, 4 distinct ones. Even though these two have multiplicities, there are 4 distinct zeros with multiplicities. Okay, folks, that is it. Good luck to you. I wish you the best. Have a wonderful day. See you later. Stupid.